Hello everyone and welcome back to the Geoscientists Voices. Today we are expanding our horizons from the ground beneath our feet to the mysteries of the solar system. We are in extraordinary moment for space exploration. The BP Colombo mission is preparing for its final orbit around Mercury, and in just a few days the Artemis 2 mission is set to launch, sending humans back to the vicinity of the moon for the first time in over half a century. Because of these milestones, it is perfect time to speak with a space scientist who bridges the gap between the traditional geophysics and planetary discovery. I am honored to be joined today by Maria Kefa, a planetary scientist and former Erasmus Mundus scholar. Maria has an incredible career path, from mapping seismic data in Germany to using AI and deep learning to analyze the impact debris on Mercury at the European Space Agency. She also brings a unique perspective as a science communicator and former journalist. Maria, thank you so much for joining me today.
Hello, and I would like to thank you for that invitation. I really admire that kind of series that you already started, and I look forward to our discussion today.
Thank you so much for really kind words, and I'm looking forward to learning a lot new things today as well. So, take me back to before you were a prestigious Erasmus Mundus scholar. Was there a specific moment, maybe a childhood memory, or looking at the stars, or a specific event later in life, where you knew I need to dedicate my career to the Earth and planetary sciences?
I would like to be honest with that. No, I just knew since forever that I really like to get involved in science and mathematics and physics. So I just knew, let's say, the direction that I would like to follow. It was just numbers that I really found interesting, solving formulas and equations and create somehow I don't know, results and conclusions based on the numbers. So many things in my life just came, and when I followed them I realized that I really liked them. So in the beginning, as I told you, I liked sciences like mathematics and especially biology. So that was my target. Like after completing the high school, I really wanted to follow the biology and to get into in the biological school. But somehow my grades didn't allow me and made me to jump to geology. Well, in the beginning, I was very disappointed. From myself. But to be honest, after that, I really found out that geology was actually the school that matched really well to me, to my profile, to the things that I would like to follow after, because the fields of geology were like uh, unlimited, and I was able to explore many things just in 4 years of studies. When it comes to the astrophysics and the master that it followed after, again, after completing the bachelor school, I knew again that like remote sensing and geophysics, it's an excellent combination that can be applied not only on Earth, but also on other planetary bodies. So this is how I stepped into that field by applying to the master that I followed after.
Well, it's really interesting how something that was basically created for studying Earth, I mean, methodologies, formulas, etc., can be applied to other planets. So the follow-up question is, how exactly does this Earth-based foundation help you when you're looking at something as distant as the splashes of rocks and debris, or ejecta, as you call it, as the new word that I just recently learned about, that are basically thrown across the surface of Mercury, which is like far, far away from us.
Well, that was also my question when I started the School of the Planetary Sciences. I think that everything started from the Earth, like all the remote sensing methods that have been developed had already started by doing things actually in the ground, and see what we see on the ground actually matches with what we see from the sky remotely. And this is how that kind of method and philosophy uh, proceeded and followed the other planetary bodies. Of course, no one can confirm what's going on or what happened on Mars or on Mercury, for example, but there are evidence that cannot be, let's say, skipped and missed. So we cannot be 100% sure even for the Earth. But at least there are some, let's say, evidence, as I said before, that if you follow some pattern, some way of thinking, you can conclude that maybe the truth is somewhere there.
But how did you have to change your mindset when you no longer like you have no opportunity to verify your findings in person? And I guess it will take you a lot of time to get the signals or pictures from Mercury. So how this total uncertainty is perceived by you, and doesn't it drive you crazy that you just do something which is not like precise, but seen from far away?
Well, yeah, I got your point. Indeed, it's hard to change the perspective from the one planetary body to another, especially when on Earth you have the opportunity to visit the sites that you test. The thing is that as geology is a multi-perspective science, and you have to combine many things using the time scale that it's not minutes or moments, it's like millions of years. I think it's somehow the same mindset that more or less used for the other planetary bodies as well. Of course, the lack of visiting the sites there is something that I feel that can be balanced by using other methods, as for example, the higher resolution of cameras as they are used on Mars, where the resolution can be in the centimeters scale. And of course, other methods that are used to provide like a more multi-aspect again conclusion. As I said before, yes, we cannot be sure, but even on Earth we have this lack of information.
I now want to talk about journey, not space journey, but your academic journey, because you've studied in Greece, in Portugal, in Italy, in Germany, and France. And for students who are hesitant about the nomadic life of an Erasmus scholar, what would you say is the biggest professional advantage of this international path?
To be honest, it's really hard to change semesters and to change the countries every semester. It was a really mandatory thing that I had to follow when I was doing my master. But on the other side, it was a huge advantage and a great experience that I got, and I will never regret, because you can see how universities work on the same topic on planetary sciences. The network is expanding super rapidly. People that you meet there, it's uh, it's somehow sure that you're gonna meet them in next conferences. And it's super nice because besides that, you understand the culture of the country that you live in. You understand the language. You feel closer between, for example, in my case, I am Greek, so I could feel closer with the other Mediterranean countries as Portugal and Italy. And also I could understand our differences. So it's a great opportunity. Of course, there were so many difficulties that followed as well. As for example, the most difficult for me was to find a new place to stay, and also the way to adapt in every country without having any idea of the language, and people they will not speak always English. Yeah, that was one of the biggest challenge there. But yeah, in the end, when you adapt, you don't want to leave.
Basically, the only like challenges that you found were like finding a place to live or like just understanding people speaking another language, which is basically barriers. They're pretty technical. You can overcome them for you.
Yeah, they're just the logistics, let's say. It's not
Logistics,
something,
yes.
yeah, but it's hard, and especially when you want to start the journey and you decide to settle somewhere, the next month you have to leave.
Yes.
So it's a kind of challenging because you get into in the school closer with the professors and the projects that are going on with conferences that happen on this country. And after you have to think the next step and move forward to the next country, the next challenges. But overall, this opportunity really helps you to build a very strong network. And that's why I would recommend anyone who wants to do that and get accepted, like just do it without thinking any difficulty that you may face. Like this happens in every case.
But Maria, I think that you maybe did not have a lot of difficulties communicating with people because you have an experience in science communication, and namely, you served as a journalist for Fast Times, a well known scientific magazine. What inspired you to step into the role of the interviewer early in your career, and how did that experience change the way you communicate your own science today?
So that was a very short experience that I had as a journalist. It was really nice. It really, put me in the position that I have to search for the people to get the interview, and after to communicate with the other parts of the magazine in order to, let's say, somehow cooperate to each other and get the final result. It was really nice. What inspired me to do that was the fact that I wanted to expand and learn more about other people's careers, as you are actually doing right
Yes.
now. And it's really nice to receive some piece of advice from other people that they are further than you. You learn from other paths as well, even if you are not supposed to follow them. But the way that other people build their careers, it's super important, and I feel that I have to do that in order to talk with other people that they live super far away from me, and also to get some ideas of how can I proceed with my life as well.
So, as someone who has been both the interviewer and the interviewee, what do you think is the most important thing geoscientists should be doing to make their work accessible to the public?
Make it simple. That's my my advice for everything, because it's not only the position that I take in an interview, but I have been also in the position when I create, let's say, research, and when I read research. I face the same difficulty in both cases as in the interview. I feel that the key point in both cases is just to talk like you have an audience full of kids that they have like very simple logic and not necessarily a background on what you are doing. And that helped me a lot to make also the way of that I'm working to make it simpler, because sometimes you have the result and the solution in front of you, but you are so stuck with many complex things that you cannot come to the conclusion. So I feel that make things like very rigid and simple to your mind first, and after to other people, is the most important thing.
I want to ask you the following question. During your time at the European Space Agency, you assessed deep learning model performance against manual mapping. Do you think that AI will eventually replace the human eye in geological mapping, or will it always require a geoscientist's intuition to validate?
I feel that even if AI will be developed in the future, um, again the human's eye will be very very important to validate it. Even if it's super strong and super fast, in the end there are many errors that can occur. Why I'm saying that is like is since human develop AI and human can make mistakes, I totally believe that also AI can make mistakes. And I can see not only from that project, but generally from other studies as well, that still, even at the present moment, and I feel also in the future, it will be really important to, like, for a geoscientist to validate with manual ways geological mapping and generally the use of AI in every method, in every project that it will be used.
I want to talk now about remote sensing uh, because you worked with the Mercury, and working on Mercury and icy moons involves a lot of remote sensing. So, what is one thing about the surface of these bodies that surprised you the most during your research?
Well, it's not actually the surface morphology that surprised me, as you said, but the conditions that actually exist at those planetary bodies. Both of them are belong in our solar system. The one, Mercury is a planet, whereas Ganymede that I worked on is a moon. So even if they belong to, let's say, different planetary categories, those bodies, uh, more or less they have some similar characteristics on their surface. And that was the thing that made me wonder how those bodies have like similar cratering patterns. It was something that the team that I worked with agreed to use the same AI methods that they developed from Mercury to Ganymede and to have like the same results, more or less, with the validation in both planetary bodies. So yeah, I would say that even both of those bodies like are different. Some similar processes create this kind of similar results on their surface.
So many people find that working so closely with the Earth, or in your case with other worlds, leads to a deeper connection to the universe. So, do you find that your scientific exploration of these distant alien landscapes has influenced your personal philosophy or your outlook on your own place here on Earth?
Totally. So in the first semester of the planetary Geosciences master, what I really felt by getting deeper in the astrophysics and generally planetary sciences was the thing that I was able to zoom in other planetary so in other solar systems, not only in ours, and get into the detail of how another exoplanetary system has been involved, what are the combination of events that create them, and etc., etc. And I could find out that at that point, I zoomed out totally from my point of view on Earth, who I am, where I'm going, and to zoom out in something that is super far away from me and make me like to be my only problem, like to find out what are the conditions in another solar system. So that was actually really helpful because I could find that myself was sometimes stuck on problems, very silly problems in my daily life that in the end of the day they have no reason to exist. And there were like other problems of other exoplanetary systems that it was actually my certain problems on those days. And it was really nice, like this kind of zoom in and zoom out of my life and my existence. create me like a very beautiful feeling, to be honest.
I understand that. I mean, everything that happens here is like so small compared to infinity. Maybe, and I'm not planetary scientist. Maybe as you work with these kind of distances and everything, like daily on a daily basis, maybe it expanded your understanding and you got insights, even not in planetary, but in like earthly things and something like that.
To be honest, this kind of uh, way of perceiving the numbers that they are, I don't know, go to infinity, it's actually make me question about like how we are still alive, like what are the possibilities to be here, to be alive, to have those people around me, to be in that place, have these events happening in my life. Well, I don't know. It makes me scared in terms of everything is completely unstable. And as human, we believe that we can control everything, our health, our people, our situations in our lives. But at the end of the day, like, I don't know, everything seems to happen just by chance. And another thing that really made me scared, that was connected also to planetary stuff, was the possibilities of not being hit by any asteroid on Earth and being, I don't know, disappeared, or I don't know, like crazy, crazy things that influence our existence on Earth. But well, we are still surviving, and that's good for now, I guess.
Yeah, I think it's good to be happy right now because we don't know what will happen today, neither from earthly troubles nor from uh, space troubles. I mean, it can end just like that, and
Exactly.
we have to live our best life. Wow, thank you so much for this like insight because I also like to think about it, and it's great to know that I'm not the only person who think about it, and professional space scientists also actually think about it.
I think everyone has these kind of thoughts. And well, from my perspective, it's good to share. Like I also ask people that are not geoscientists and have like a zero connection with that. And yeah, I think more or less it's like the human spheres that connect to each other with the same the same fears like of this kind of planetary problems.
So I want to go deeper into the space topics this time from more technical point of view, because we are in an extraordinary month for space exploration. The Artemis 2 crew is set to launch this month, February, to fly around
Mhm.
the moon. So, from a geologist perspective, how do you think having humans back there actually looking at the surface of the moon with their own eyes will change the kind of questions you and your colleagues at the European Space Agency ask about planetary evolution?
Well, I feel that it was nice having this gap between the Apollo missions and Artemis, because during those years there were many methods that have been developed, and also many questions that arose from those research that has been done. I feel that it's a nice opportunity to solve somehow or give some answers, partially maybe, to those questions. Of course, new questions will arise because that's a cycle with research and science. And it's a great opportunity. Like, I don't know what to say. It's like super fascinating because all the technology has changed. Nothing is the same as before. I'm gonna go a bit further on that. Like, I met many people that asked me, my opinion about the planetary sciences and why they are so important for people's lives, like we are gonna die. Why do we care about other planets? Well, we do care actually because the technology that we develop in order to go to other planetary bodies and send satellites or to develop better cameras and resolutions and everything, in 10 years, it will come back to us, to our phones, to our daily lives. So it's not that we have the results on the same day that the technology is developed for the um, planetary science, but somehow it will come back to us.
So, what are your thoughts on the perspective of humans colonizing other planets like Mars and maybe Moon, etc.? Is it a scientific necessity, or should we remain focused on exploration from afar?
Well, for now, I tend not to believe these super optimistic scenarios. They sound nice, and I feel that they also help technologies to grow. But I don't necessarily feel that it's important for human to colonize to other planets, since we live in the best and the planet that actually brought us in life. I think it's our home, and why should we leave from our home? Like, why to take Mars and create the conditions there to be as on Earth, since we have Earth, and it seems that we don't protect that much Earth. So if we try and we want so much to move to another planetary body, I think first it's super important to take care of our home and make Earth as before a little bit in terms of conditions. And yeah, that's my opinion about that.
I want to talk about the perspectives now, the block of questions about it. And the first one is that about your personal career, because after such a diverse journey through the Erasmus program and European Space Agency, what are your plans for your future career? Where do you hope your research takes you next?
After the completion of the master, that was in the previous summer, I moved to the project with ESA, and after that, so I took like a small break, let's say, because I wanted to prepare some scientific papers that I'm doing together with my supervisor in my last internship. Now, I'm currently involved in other projects as well with the University of Salzburg in Austria. And my plans are involved doing probably a PhD, but I'm still searching for the right project. But also, I look for if the PhD will not be possible for me, I will search for a job probably that combines research and business somehow, like together, because I like this combination and I don't want to leave research behind.
Sure. Well, I really wish you luck in everything that you do because your abilities definitely should be put to use in for the good of our planet and for your comfort and advancement as well, I think.
Thank you so much for that.
So, and also I want to learn about your perspective generally on space research. So, your opinion is, besides the Artemis 2 milestone, what other mission or upcoming technological advancement are you most excited about for the next decade of geosciences?
So I think that missions that will happen also in the near future. I'm talking about the MMX mission that will go to Phobos, to the moon of Mars, and will take a sample from there and bring it back on Earth. I found it like really excited and super interesting having this kind of, as we said before, confirmation about what we see not only remotely, but also having a real sample that can give us a lot of answers. So for me, right now, I found very interesting this kind of missions, and of course missions that they go really out of our solar system and look for exoplanets and uh, extra solar systems that do not belong in ours. All the fascinating stuff from that is like that you can explore things that they're super far away from you, and you are able to take information and create a research, create science by observing the other stars.
Yeah, it's awesome. The only thing that bugs me is like they send the satellite or a rocket, and then like you wait for 5 years or 10 years before they actually give you some results, and you're like, wow, it I'm excited about it, but I will forget about it like the next couple of years until the news will tell me, okay, it's now back.
Well, that's a pain, and I understand that, but I feel that it's a good to have this kind of gap because before having the satellite getting there to the final let's say stop, it's nice that because you can create some kind of philosophical questions or a preparation in science, and maybe having things from previous missions or other assumptions from other scientists, you can find things that you can actually confirm when you have the satellite getting in the planetary body that it has to.
So, looking at the future of planetary science and the next generation of researchers, in just one single word, how do you describe the future of geosciences?
One word, limitless. That's that's the word I think that can describe that. I don't think that it will never end. I don't think that there is any barrier or margin that geosciences or planetary sciences will never face. I think the combination with the technology, the new methods, the people's minds, the machines' minds as well, it will create, I don't know, new things that we cannot believe. Like if we say it right now, it's impossible to perceive them, but in the future they might be confirmed, which is crazy.
Yeah, it's crazy, but it's also inspiring. And I think, and I hope, and I think that I know that you'll definitely be the one who will contribute to having these new machines working or these new discoveries or something like that. And I really wish that in your new position, you will contribute a lot to the discoveries that will be all over the newspapers and TV channels and our
Oh my God,
minds.
thank you so much. I hope that too.
Yes. Maria, well, thank you so much for sharing your journey with us today. It is truly inspiring to see how foundation in Earth geology can open doors to understanding the furthest reaches of the solar system. Your work reminds us that whether we are sticking sensors in the dirt here at home or analyzing satellites images of Mercury, we are all part of the same grand story of discovery.
Well, thank you so much. I really enjoyed that. And best of wishes for the continuation of this geoscientist voices journey.
Maria, thank you so much. And to everyone watching, as we look toward the Artemis 2 launch and the future of planetary exploration, remember that the next great voice in geosciences could be yours. So thank you for joining us on Geoscientist Voices, and we'll see you in the next episode.